brief outing on our understanding of kinds of stability, and we understand stability versus position of center of gravity. Now what I'm going to deliver to you is a small illustration which would be about toppling, which is about stability. What we have is a very rough inclined plane which will prevent slipping. This is a fixed rough inclined plane making an angle 30 degrees with the horizontal, right? That's a situation. Now we now have a uniform cylinder of diameter 8 centimeters, means radius of the cylinder is 4 centimeters. Now we want to select the height of the cylinder. We want to select the height of the cylinder or the maximum height of the cylinder, so that when it's placed on the rough inclined plane, it does not topple. It does not topple. So let's understand the progression of events. First of all, imagine that the height of the cylinder is very small. Let's say the height of the cylinder, capital H, is very small. When the height of the cylinder is very small, realize that the line of action of its weight, will be confined to the base AD, and it will not topple. Not topple. Not topple. Right? Now, as I keep adding to the height, everything else remaining the same, if I keep adding to the height, what is going to happen is the center of gravity will keep moving up, and its line of action, the center of gravity will keep moving up, and its line of action will come closer and closer and closer to A. But as long as the line of action of the weight falls within AD, it's not going to topple. Now, eventually there is a limiting state. A certain height, capital H, equal to 2h, for which the line of action of the weight just about passes through this corner A, just about passes through this end A of the base. Now, until then, it's fine. If I increase the height slightly more than this, and I come to this height, more than this 2h, then the line of action will go past AD. Let me call it, go past this base, which is AD, and I've called this B, so let me call this B, right? We'll go past this AD and it'll topple, right? It's not going to topple here. It'll be on the verge of toppling here. That means you can't have a height more than 2h, because if you had a height more than 2h, the line of action of the weight will not be confined to AD, and toppling about A will take place. Again, there is no question of slipping here, because this surface is very, very rough. You won't expect slipping to take place, right? Now, so this is the limiting height or the maximum possible height, 2h. Very clearly, look at this. If this is 30 degrees, the normal, that means the axis of the cylinder, which is perpendicular to the inclined plane, will make an angle 30 degrees with the vertical. This is the radius of the cylinder, and very clearly R by H, as you can see, R by H, H is half the height. See, the center of gravity is located halfway on the axis, exactly at the midpoint of this 2h, right? And R divided by H is tan 30 degrees. Tan 30 degrees, which is 1 by root 3, right? So very clearly H is R root 3. H is R root 3, where R is 8 centimeters. So this is like 8 root 3 centimeters. So what is the required height? The required height is 2h. Capital H is 2h, which is like 16 root 3 centimeters. If you increase the height beyond 16 root 3 centimeters, you get into this state, and the line of action of the weight will no longer be confined to the base of the cylinder, and you'll get into this state where toppling occurs. So from a very small height, if you keep on increasing the height, the center of gravity goes higher and higher above this inclined plane, and at some point when it comes to this, it'll be on the verge of toppling. Further increase in height over and above this point would be some kind of a state like this, and you would expect toppling to take place about A. Yes or no? So this was an interesting situation. We'll look at a few more. Thank you so much for the time being. Bye bye.